Hi dear students, welcome to our channel Math Solutions by Pani. Here we are in determinants 4e exercise. Yeah, in exercise 4e, we are discussing about the consistency of system of equations. What is the meaning of consistence? Consistence. What is inconsistent? Both the meaning we will discuss. A system of equations having the solution. A system of equations is said to have is said to have is said to be consistent, said to be consistent if its solutions, if its solution exists one or more solutions. Suppose a system of equation is said to be inconsistent, inconsistent if it does not having the solution. So solution is there, its solution is there, consistent. Does not having solution, it is inconsistent. I hope you understand, students. Okay. Later, the solution of a system of linear equations, either two variables or three variables. Suppose the system of linear equations in three variables we will discuss directly. So a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3, or system of equations. So these system of equations can be written as ax is equal to b form, where A equal to coefficient matrix, that means XYZ coefficients A1, B1, C1, A2, B2, C2, A3, B3, C3. Next, capital X is the solution matrix X, Y, Z, and capital B equal to constant matrix, that is D1, D2, D3. Okay, dear students, this is the way. So by using this system of equations, we can find the solution by using matrix method or using inverse of a matrix. This method is called matrix inverse matrix method, or simply matrix method. So Ax is equal to B given system of equations, no? So pre-multiplying on both sides with A inverse to the equation Ax is equal to B. So this is pre-multiplied by A inverse. So again we have the formula A inverse into A equal to A into A inverse equal to identity matrix. So this value is I into X is equal to A inverse B. That implies that identity matrix into same matrix is same matrix, that is X equal to A inverse of B. X is called solution matrix. X is equal to A inverse of B. When this will be exist, A inverse, when it will be, if det A is not equal to 0, the solution will exist. Otherwise, that means A is singular, non-singular. That is, A is non-singular. If it is singular matrix, the solution we cannot find. That time it is inconsistent. So I hope you understand, students. We'll move to the exercise 4e and we'll solve the problems based on that. So let us have a discussion. The first question here. The first question is, examine the consistency of the system of equations. First, given system of equations. Given system of equations. X plus 2y is equal to 2. 2x plus 3y is equal to 3. This system of equations write in this form. Ax is equal to b form. Write in the form of Ax is equal to b, where a is equal to, here two variables, no, so we can write easily. A equal to x and y coefficients in both the equations 1, 2, 2, 3. Next, capital X is equal to solution set x, y, and capital B is equal to constant matrix, that is 2, 3. To find the solution by this method is called inverse method, matrix inversion method, or simply the telling us the method is matrix method. This method is known as matrix method. In some other areas, this is matrix inversion method. Matrix inversion method. So anyway, any terminology they can use, dear students. So to get the solution of this matrix, first find out the determinant of this. Determinant of ABCD is what? AD minus BC only, no? So 3 minus 4, which is equal to minus 1, cannot be 0. That implies A inverse exists. Whenever A inverse exists, solution will be there. It is consistent. We will write it. So we need to write Ax is equal to B. To get A inverse, we need to calculate adjoint A. No? Adjoint A for 2 by 2 matrix we already done in the previous videos. Interchanging of diagonal elements 3, 1, and sign changing of non-diagonal elements. So adjoint A we got, and data also we got it as minus 1. Data is equal to also minus 1. This is the another information. Again you have to follow that multiply pre-inverse with A inverse. So that implies that Ix is equal to A inverse of B. That implies X is equal to A inverse of B. So X is equal to A inverse means 1 by det A into adjoint A into B. That is equal to 1 by det A value is minus 1. Adjoint A matrix 3 minus 2 minus 2 1 into B matrix 2 3. So which is equal to minus 3 into 2 6 minus 2 into 3 minus 6 minus 2 into 2 minus 4 plus 1 into 3 3. So which is equal to minus 0, minus 1. Therefore, the solution matrix multiplying by minus x is equal to 0, 1. This is equal to xy. Whenever solution is there, it is constant. It is consistent. Solution is not there means inconsistent, dear students. I hope you understand. We'll move on to other question. This question also we will do it in this similar way. Examine the consistency of the system of equations. The above system of equations, the above equations can be written as ax is equal to b. So where a is equal to 2 minus 1, 1, 1, x equal to solution matrix, that is xy, and b equal to 5 comma 4. So for this, immediately calculate determinant of a. So determinant of a equal to 2 minus of minus 1, 2 plus 1, which is equal to 3, that implies equal to 0. A inverse exists. Whenever A inverse exists, adjoint A calculate. Adjoint A equal to interchanging of diagonal elements and sign changing of non-diagonal elements. Later, we can proceed AX equal to B. That implies pre-multiplying with A inverse. That implies A inverse into A is identity matrix. So that implies that X is equal to A inverse of B. So that implies that X equal to A inverse means 1 by delta into adjoint A into B. So X equal to 1 by delta value is 3. Adjoint A value 1, 1 minus 1, 2 into B value 5, 4. So which is equal to 1 by 3. Matrix multiplication 5 plus 4, 9. Minus 5 plus 6 plus 8. Sorry. So 9, 3 into 1 by 3. So therefore x equal to, dividing by 3, it will becomes 3 and 1. So therefore the solution set is, solution matrix is capital X equal to 3, 1. Whenever solution is there, the given system is consistent. Next, examine the consistency of the system of equations. First, the given system of equations, write in the form of ax equal to b. The given system of equations, or simply the given equations, can be written as ax is equal to b form, where a equal to 1, 3, 2, 6, capital X equal to XY and capital B equal to 5, 8. After completing of this, find out determinant of A. So determinant of A 6 minus 6 equal to 0. That implies A is singular. A is singular. Whenever the matrix is singular, A inverse does not exist. A inverse does not exist. Whenever A inverse does not exist, solution we cannot find, it is inconsistent, does not exist. Therefore, system is we cannot find A inverse does not means we cannot find the solution. Given system is inconsistent. Inconsistent. Okay, students, in the whatever the way we applied inconsistent. Yeah, we'll move to next questions. Yeah, previously net problem is there, now it will be. So in second section, section 2, examine the consistency. Question number 1, examine the consistency of the equations x plus y plus z is equal to 1. Next, 2x plus 3y plus 2z equal to 2. Ax plus ay plus 2az is equal to 4. This is the data, dear students. So what we have to do is with this, examine the consistency. They are not asking to find whether it is find. They are not asking to find the solutions. It is not. Even here we got the solutions also, but no need to find. But here, according to the question, I will give the answer. Given system of equations, given system of equations can be written in the form of, otherwise written as ax is equal to b, where a equal to 1, 1, 1, x, y, z coefficients in all the equations, 2, 3, 2, a, 2a. Okay, dear students. Next, capital X equal to solution matrix x, y, z. Next, B equal to constant matrix 1, 2, 4. So, to decide the consistency, we need to find the determinant of A. So, det A equal to 1, 1, 1, 2, 3, 2, A, 2A. We know that how to expand this. 1 into 6a minus 2a minus 1 into 4a minus 2a plus 1 into 2a minus 3a. So 4a minus 2a minus a, that is equal to a, not equal to 0. Whenever det a is not equal to 0, that implies a is non-singular, a is non-singular, a inverse exists. Whenever a inverse exists, the given system has the solution. Whenever it has the solution, then it is consistent. Okay, student, that is the reason. That's all. So, question number 2 in this, examine the consistency of the equations 3x minus y minus 2z equal to 2, 2y minus z equal to minus 1, 3x minus 5y equal to 3. What we have to do? First, the given system of equations can be written as ax is equal to b form. Later, what we have to do? You mentioned that what is a, what is b, what is c. 3 minus 1 minus 2, 0, 2 minus 1, 3 minus 5, 0. X equal to x, y, z. B equal to constant matrix 2 minus 1, 3. After that, find out the determinant of A. So, det of 3 minus 1 minus 2, 0, 2 minus 1, 3 minus 5, 0. So, plus minus plus, 3 into 0 minus 5 plus 1 into 0 plus 3 minus 2 into 0 minus 6 minus 15 plus 3 plus 12 equal to 0. Det A equal to 0, that implies A is singular. Whenever A is singular, A inverse does not exist. A inverse does not exist means what? Solution we cannot find. Therefore, given system has no solution. Then it is inconsistent. Same topic will run in my other channel, Maths with Panindra, but it will take time to explain. We have already completed 4B. After 4C, 4D exercises, it comes in my other channel. Live it comes there also. Okay, we'll move to question number 3, dear students. In the question number 3, examine the consistency the consistency, examine the consistency of the system of equations, of the system of equations. What is that equations? 5x minus y plus 4z is equal to 5, 2x plus 3y plus 5z is equal to 2, and 5x minus 2y plus 6z is equal to minus 1. Given system of equations, can be written as ax is equal to b, where a equal to 5 minus 1 4, 2 3 5, 5 minus 2 6, x equal to solution set x y z, and constant matrix B equal to 5 2 minus 1. After this, we can find the determinant of A to decide whether it is consistent or not. Plus minus plus 5 minus 1 4, 2 3 5, 5 minus 2 6. So 5 into 18 minus of minus 10 plus 1 into 12 minus 25 plus 4 into minus 4 minus 15, 28 into 5, 12 minus 25 is minus 13, plus 4 into minus 19, 140 minus 13, so it will be 140 minus 89, so anyway not equal to 0. So det A not equal to 0, that implies A inverse exists. Whenever A inverse exists, given system has solution. Given system has solution. Given system has solution, and it is consistent. Okay, dear students, I'm going to end the session. The rest of the questions in second bit, 4 questions. In third bit also 4 questions we will discuss in the next class. 4 not 6 questions are there. We will discuss in the next class. Thank you for joining the session. In the meanwhile, power cut is there. That's why that 5 minutes the stream will be little inconvenient. Thank you for your support.